is Eugene. I'm from Melbourne Engineering Consultants in Bentley. Today we're going through a typical structural design which entails a 2-unit development, and we're going to go through the process of how it's been designed.
So we have this set of structural drawings which shows what are the process we have gone through and the design which gives you the better value of your investment and development. The first page is showing as a note which covers all the requirement for the site construction, including the site preparation. Secondly, the footing notes, the concrete grades required for individually for blinding concrete, raft, strip footing, so on, and the required ground covers for the reinforcement. The other notes is like what are the footing founding depths, steel work quality as per the Australian standards, framing notes, general notes for the soil, notes for the root barrier, and so on. And here we have external lintel table which we need to use if you are designing a brick wall on the brick veneer. So you need to have the angle lintels for brick to support. And here is the typical roof truss notes. On the page number 2 we have the footing design which we have designed for especially for this project as a waffle slab, which is of course economical and energy efficient in terms of saving the power, because we in waffle slab we use the polystyrene blocks and they are hollow, so you save lots of concrete, and not only the concrete but you also save the heat passing through the ground from the concrete slab. So it's like an insulation barrier between the ground and your concrete slab, which saves a lot. This is the typical set of the structural drawing showing the footing, where we have this garage slab here, garage slab, typical step down details. We have 2 units side by side, and at the back we have the decking, timber decking. And here on the we have typical details for the same footing, what kind of requirement need, like a kind of how deep the waffle ports will be, reinforcement, and the conventional decking slab required. On the page number 3 we have typical details for the footing, how it's going to look like, stump details for the decking, and the typical section for apron required for the water protection from the footing. Typical details again for the stepping details, step down details for the steps, step down detail for between 2 units, and so on. On the next page we have the typical detailing for piping, how's the sewer pipe and the rainwater drainage pipe going to interact with my concrete footing. So these are the typical details, including the sewer pipe and if there is on easement. On the next page we have this typical first floor framing plan which shows beam layout, and of course it shows the layout of our floor joists. We have designed our beam. So the posy, if we're designing as someone is designing the posy trusses, they can assume how we have designed the beam and the load transfer accordingly. These are the typical system we have here, and on the exterior we have the lightweight roof, and internal of course we have the habitable area, internal area with the staircases. And typical detail again on this one, how the double joist and typical triple joist my new beam will sit on. On the next page we have the typical roof, which is going to be a truss roof designed by the roof manufacturer, and this design is saying how is the roof designed for, what's the roof capacity. It's designed for tiles roof. Normally some places we design for tin roof as well, which is lighter. On this sheet we are showing the typical details how my first floor posies or floor joists is going to be connected to each other and give you a better system, more vibrant, less vibration into the system. Typical connection details for the steel beams. And next page is typical details for the roof, how it's going to the eaves working, parapet working with the lintels connection, how's the holding down with my beams and the column going to work. And next last sheet we have this typical member schedule for all beams and the lintels. Thank you very much.
Thank you very much for watching. Have a good day. G'day, it's Eugene here from Melbourne Engineering. Today we're out on site showing the same project, the construction stage. We're showing the structure.
This one here showing the roof process manufactured by the third party and how they're connecting with my roof walls, and showing the bracing layout, showing the first floor lintels we have discussed in our structural design, and we are showing the bracing here, hardwood bracing on the other side, and this outside is the roof. So this is a big lintel sitting on the other side on double studs. That's why we save the money on the projects. Here is showing again on the corner bracing, which is hardwood, and this is a stud wall with a D-brace, strap metal, another wall here, and this is the showing here positive process. It's because the under construction still. So we are showing two positives here, sitting at 40 centers with a steel beam. And the board is again a new internal area. We got to have it on this one, first floor, all the bedrooms, and the living area we will have the carpet or hard timber flooring, something like that. Same thing here again. The lintel is wide open lintel with the double strap on either end, and the roof trusses sitting on it with the hardwood bracing either end. It's got to be fair. Same thing, double D braces. As for Australian standards. This wall is my party wall. So we have one 90mm stud wall this side, shaft liner in the middle for the sound insulation and the fire protection, and the other side we have another timber stud wall, which is my load bearing wall. So half of the trusses is coming on this one, and half of the other side of the roof trusses will be coming on other side. It's like a more fireproof and more sound insulation wall with the shaft liner in. Here this is showing the external roof with the roof rafters at 600 centers and one steel beam which is picking my this side. All internal walls they are non-load bearing, only the load bearing trusses are transferring the load on one end to other end. So internal walls are just load bearing. Here this is again a lintel at the top we have, and double stud sitting on either end with the hardwood bracing just for the wind brace, and double string strap bracing as a D, and cross bracing on the external wall to transfer the wind load. So here we're showing on the ground floor, so showing the balcony over. This is the balcony floor joists running out, and the internal floor joists as 450 centers which are posies, and I have my steel beam which is sitting on the post as a bolted connection, and the steel beam is coming out on the way here and taking this cantilevering out and picking my other side's timber beam which is bolted to my steel beam. So all the posies in this direction are at 450 centers, which is picking my first floor level. Internal walls in here are non-load bearing, so we don't need any lintels inside, only the outside are the load bearing walls. Most of the first floor structure is sitting on my steel beams or timber beams. Here is showing, here this one is garage beam, it's a T section, and it's picking my first floor steel beam with a stub column which show you other side. So that's again a garage lintel beam, and I'm taking the point load from the steel beam which is picking my first floor walls and the roof, and the load transferred through that steel stub column and transferring onto the garage lintel which is a T section. Again outside are the roof rafters which are 600 centers which are just for the tin roof, and internals are the posies roof trusses for the floor trusses which are at 450 centers for internal areas. Another one here is a steel beam which is putting my other two major beams, and as here's the steel post connection to the beam. And on the base there is a post connection to the ground which is on the concrete, bolted to the concrete with M16 bolts with the base plate. And here the concrete is again, as we discussed on the video on the structural drawings, is this is on the waffle slab, and this is a step down here which we already show the detail on our drawing, the steps and everything. Here is again the same waffle slab, which is more big area. Here we have the steel beam, which is acting as a portal frame as well on both ends, and picking my outside brick wall as acting as a T-section for my So this angle arcs welded to the PFC is going to take my brick wall over this height. All external wall here are brick veneer on the ground floor, and the first floor is lightweight polystyrene cladding. Again, the steel beam frame connection, the steel post and steel beam, and again on the other side the steel post again with a 3 and 16 bolt connection, and the timber beam is connecting the steel beam and transferring the load on the side. These steel beams also acting as a portal frame for the structure, which is required for in terms of the stability of the wind. And again here we have the wide open window, a sliding stagger door. The steel beam has been designed for it, and outside we have the brick veneer, which is the brick we're going to sit on this steel beam and coming up as a parapet, and it's a lightweight roof again.
This is a scope to show you how big this 2-unit development structure is.
The front area of the house showing the garage window on the left, and the steel beam showing as a cantilevering out and picking my first floor and the roof on it. If you go on towards the right, there is the entry and the entry point and the big windows, 2 double big windows, and we have a step down in the footing there, which is about 800 mil, and we have on the next door dwelling, which is the same as this one, but it's on higher side, and this other end is the lower side. Same design, same construction sequence. We have the garage on the right, and the T-section, T steel beam sitting on it, and the cantilevering out and picking on the beam on the other side, and which is picking my first floor and the roof over. The garage is on double brick walls, all 3 sides, and in the front we have the steel manufactured T-section. And all the footing system is on the waffle to save more energy and fast workmanship.